Hello and welcome back to our channel where we explore the latest advancement in technology. I am thrilled to dive into the topic of data capturing and recording in vehicle network communication. Let's buckle up and get started. My name is Akash and I am the senior test engineer at Techteal Engineering. Just like our body have intricate systems that connect different parts, vehicles have an equally complex network of communication. Every time you push a button, turn the steering wheel, and hit the brakes, the data is being exchanged between the various components in your car. Automotive systems rely on a board of variety communication technologies between sensors, actuators, electronic control units to be able to capture and record Ethernet traffic in vehicles, which can be used for debugging, troubleshooting, and performance analysis. You require a flexible solution that captures all your in-vehicle data regardless of type, such as CAN, CAN-FD, FlexRay, LIN, Automotive, Ethernet, ZS, analog, etc. There are many ways to log and tap data from an in-vehicle network, but our experience has found the Technica Capture modules to be especially powerful and flexible. For proper timestamping and synchronization, support of 1588 and GPTP protocols is desired. The recorded data is packed into Ethernet MAC frames on layer 2 and forwarded over a standard Ethernet network to standard PC or a dedicated logger if available. TechMP from Technica Engineering is well established and proven, but going towards ASAM CMP might be interesting. The ASAM is a standardization association that focuses on standardizing the data exchange between the many tools used in the automotive development process. CMP stands for Capture Module Protocol. So it is an open standard that defines the communication between the capture modules and data sinks to monitor in-vehicle bus communication and sensor data, and will be even more widely used. Both TechMP and ASAM Capture Module Protocol provide a standardized way to capture and record all this data, regardless of the underlying communication protocol. TechMP or ASAM Capture Module Protocol are both transported over Ethernet, and it defines the mapping rules for vehicle bus communication and sensor data. The ASAM supported protocol CMP makes it possible to use a variety of different capture modules and data sinks from different vendors as long as they all support ASAM CMP standard. In summary, such a protocol provides a number of advantages including scalability, flexibility, interoperability. What is scalability? It can be used to scale from small system with a few capture modules to large systems with hundreds of capture modules. Flexibility, it supports a wide variety of vehicle bus communication protocols and sensor data formats. Interoperability, ASAM CMP is an open standard, so capture modules and data sinks from different vendors can be used together. Now I'm going to show you few of the descriptions or the in-depth of the TechMP and CMP fields. So first is the CM ID. So it is capture module ID. Each capture module can be configured with a unique ID. This ID can be used to identify different modules if they are used in the same network. For example, if you have something like CAN and FlexRay and other protocols, it can be identified with this capture module ID, and it has a data type uint16 in the TechMP. And next is the counter. The counter is incremented for each CMP or TechMP frame sent from a capture module. The capture module ID field is same for all interfaces in this case. So the next field is version. The used version of the CMP or TechMP protocol is described here, and it is uint8. The next field is message type, description of the payload function, weather status, configuration of or bus data, and this is also uint8. And then there is a data type, description of the type of source data, example CAN, LIN, FlexRay, Ethernet, undefined, and voltage current. These types are pre-configured and fixed. So there is a next field called reserved, so it is pre-filled with 0 0 in the hex, and the next field is CM flags, that is capture module flags. This represents the start of the segment and the end of the segment. Channel ID that uniquely identifies the log data bus link on the IVN. Timestamp. The timestamp is the time in the past 1 nanosecond since. Length. It shows the length of the source data. The next part is data flags. It is 16-bit field. The data flag refers to the messages transmitted on the in-vehicle networking. It can be 100 base T1, 1000 base T1, FlexRay, CAN, CAN-FT, LIN. And the next part is source data, which is optional. Data transfer from the vehicle in-vehicle networking, and it can be source data. Now back to the devices itself. This modular concept of different devices open up for you to pick and choose what you need for your particular use case. To some extent, you can cascade the different devices. Otherwise, you need a regular switch to gather the data before sending to your logger, laptop or cloud. The common features for all capture modules are: it is automotive grade and robust with 12 to 24 volt support, and it uses 802.1 AS for network time synchronization. As mentioned already, the open timestamp protocol TechMP and CMP has a source timestamping of 40 nanosecond resolution. Isn't that too accurate and precise? About 100 millisecond high speed startup and startup buffer cater for the ability to capture vehicle startup sequences long before any logger is ready, as well as wake up capable. There is output traffic shaping to cater for bursts of traffic, CAN-FT, FlexRay transmission, where you can inject traffic back to the ECUs, and of course a web server that I will now show you. I'll now start up one of the capture modules. I pick up capture module CAN combo from Technica Engineering, and I'll show you each and every feature of it and each and every tab of it, and show you how it works. Since each and every capture module has its unique IP address, I will now go and walk through with the CAN combo, and I will show you how to configure the IP address in your PC first, and then how to log in to the web page of this CAN combo. As soon as you log in, you can see here the system update. So this option is used to update the firmware on the devices. The process of updating a firmware or license is explained in the user manual in the chapter 7. Let me explain you about the rotary switch in detail. So this field indicates the current position of the rotary switch. By default, the rotary switch position is on 0 right now, and this can be seen behind the device where you can see this blue one. You can rotate the position of the rotary switch, and with the rotary switch it is possible to select an IP address to access the device. This is so-called hardware IP address, a shortcut for hardware determined IP address. For each hardware variant of capture modules, a different IP address range has been defined. Right now I'm using a CAN combo, so rotary switch on 0 represents IP address 10.104.3.64, and rotary switch on 1 represents 10.104.3.65, and so on up to 10.104.3.79 for rotary switch F, so which represent a reset. So the rotary switch in position 0 to D. So what right now it is 0. What does it represent from 0 to D? If the rotary switch is set to a position from 0 to D, the IP address of the device is not configurable via software and can only be changed using the rotary switch. The IP address will be configured according to the table. The rotary switch in position E. In this position, IP address is configurable. The configuration can be done either via the website, System Information tab, or using a UDP configuration message. Then there is a rotary switch position F, and the position F offers the user possibility to perform a factory reset of the device. So this is all about the rotary switch, and if you want to know in detail about the rotary switch, maybe you can use the user manual along with the device that you get. So you can see here license information, which has serial number, maintenance date, features, and you can also see the firmware information. And there is a device information which has a rotary switch, hardware version, MAC address, control IP address, hardware address, and capture module ID. And there is a device physical information, which is host physical ID, 100 base T15 ID, GPA 5 ID. GPA is a port in a device, hardware device. So here the features, the list of all the features that are covered under the license are mentioned here. There can be several modes of the license: unlicensed, temporal, permanent, expired. So what are these? So no license is available for this feature if it is unlicensed, and right now it is showing as unlicensed. Temporal, it shows temporal if the license is granted for the limited amount of time mentioned in the web page. And there will be one more option called permanent. The license is granted permanently for this device. And it shows expired if the license is expired and the feature cannot be used anymore. So after system information, let's go to the control panel tab, and here we have a power the reset system. This button will perform a soft reset of the capture module CAN combo. Any unsaved changes will be lost. Then there is a system parameters. With this field, the time of the capture module can be set to be taken over as a reference for the timestamp in the TechMP protocol. This setting can also be useful in the case CAN combo is not connected to a time master to have a timestamp close to the real time. And now there is a configuration. So let's see what's there in the configuration. There is an option to modify the configuration name. You have an option to import a configuration. You can export the configuration from here, export it in a JSON type. You have an option to make it a default, and there is an option to overwrite user configuration, overwrite user events. And there is a sleep parameters. In the sleep parameters, you have a standby mode, sleep mode, wake up line 1 actuator, wake up line 2 actuator. So wake up line 1 signals that there are reasons to stay awake. So let's move to the status tab. In this section of the website, you can find a graphical overview of the device representing its main elements. So it has a control CPU, host port, SPI, logging ports, and in-vehicle networking ports. So CAN, CAN-FT, RS-232, FlexRay. Each of the elements offer several configuration possibilities to you, and we will get to know everything, every ports one by one. Capture module Ethernet ports have color indicators in the web interface regarding the link up is indicated. In the solid green. Logging output only relevant for output ports is marked with an orange bar. You will see somewhere here as a logging. Each port where the option output is used to redirect the traffic on CAN or CAN-FT, FlexRay, and RS-232 ports will be marked this way. So we have a GB port here. The capture module CAN combo is equipped with a GB port, which can be used as one of the main interface to interact with the device connected to the logging network. It can be mainly used for logging and time synchronization. So you can see here it can act as a slave or master or grandmaster. So when you make it as a slave, then you can select which mode the PTP should behave it as. It is a GPTP or PTP version 2. and you can name the port name, and you have the configuration port option, stated message port, and control message. You can enable and disable as per your need. Let's see what's there in this SPI. So in this SPI you have an option of ether type where you can select TechMP or legacy. So what is TechMP? The generated Ethernet frames are identified with ether type this 0x99FE, and the legacy, that is following 100% TechMP specification. And if you select a legacy, the generated Ethernet frames are identified with ether type 0x2090. The frame layout is the same, but some of the fields have a different name. The device should also be used in TechMP ether type unless and under special condition. So what is enable traffic shaping? The captured traffic is forwarded to 1000 base T port and 100 base T1 port configured as logging port to be sent to a data logger, a computer, or any captured device of storing the data in trace files. And once this is enabled, the maximum traffic bandwidth desired for the output through the logging port must be selected. So here you can select the maximum traffic bandwidth. The default traffic is, you saw it is 100%. And then there is an option for delay for logging. So link up detected. For this option, a link must be established in all ports selected as output 2. Then there is a time master detected. Unlike the link up detected, this option is dependent on the config port selected. If this option is selected, captured data will be sent after an IEEE 802.1 AS master is detected on the logging port. Then there is a control message data logger ready detected. Unlike the link up detected, this option is dependent on the config port selected. So these two are dependent on the config port selected. We have an option of packetization mode. So if this is disabled, each incoming Ethernet frame will be encapsulated in a separate TechMP frame. If it is optimized, so several Ethernet frames will be combined in a TechMP frame, optimizing as much as possible the bandwidth in the logging port. And what if it is monotone? So several Ethernet frames will be combined in a TechMP frame, guaranteeing that the timestamp of the TechMP frame will increase always monotonously for a given interface ID. So yes, you can save it once your configuration is done, and save and apply configuration. The CAN combo is provided with the 6 CAN or CAN-FT ports. To connect to any of these ports, a bus termination resistor of 1200 ohms is needed. Each of these ports require a basic configuration. So if you click on this and you enter here, and you can name the port and you can select to which one it is going to output. It is none, or it is 100 base T1, or it is going to the GB as explained earlier. And you can name the interface ID that can be reflected in the frames in the TechMP. Then it can be output to any of the option. I would like to tell more about the interface ID. This option can be used to specify an ID that uniquely identifies a link on the in-vehicle networking in hex format. Yes, so you can see here it's in the hex format that is being monitored. So the maximum size of this field is 4 bytes. The interface ID can be used to identify the original link connected to the CAN or CAN-FT ECU. Identify interface ID 0 is not allowed according to the TechMP protocol. So for further information, you can just go back to my previous video, which explained more about the TechMP specification. We have an option of CAN type. So this provides you to select the difference between CAN or CAN-FD, and then there is a CAN mode. Here you have an option to select passive node or active node, and then there is a keep awake reason channel. So keep awake reason bus, if it is selected, port is monitored. If traffic is detected on this port, the device must stay in full operation and cannot enter sleep mode. And then there is a wake up source. This option enables to use the corresponding CAN port to wake up the capture module. So if this is not enabled, if the device goes to the sleep mode, it may not be able to wake up again. So now we have an advanced CAN configuration, and here you can see we have specific parameters like minimum time quantum, baud rate prescaler, information processing time, and nominal propagation segment, nominal phase segment, nominal synchronization jump width. So you can configure as per your requirement. And then let's go to the FlexRay port. So what are the options that we have in a FlexRay? So you can name the port, and you can select the output port, which port to be output port. It is 100-T1 or GBA. And again, it's the same option that you have here, keep awake reason channel. And I had mentioned earlier that if you enable it, it will be awake, and if you disable this wake up source, then if the device enter into the sleep mode, then it is not going to awake. And then you have a message with error. So here you can see the message with error. And then there is a FlexRay transmission mode. This is an optional feature configuring the mode of FlexRay transmission. So XCP, with this option, the port sends XCP command configured in the XCP tab. And there is a simulation and replay. These two are a licensed feature. A dedicated license is needed for this feature. With this option, the user can configure the FlexRay port on the CAN combo as a FlexRay node. And replay, this option enables the user to send FlexRay frames through GBA port towards the connected FlexRay node. So now let's go to the RS-232 port and see what all we can configure here. So you can rename the port here, and the data captured by this device can be forwarded to the logging network so that it can be analyzed and stored if needed on the logging endpoint. So the GB port and the 100-T1 port is available in the CAN combo. It can be configured for this purpose. Now we have a protocol type. You can select between two ways of receiving the serial stream on the RS-232 interface. Based on the selected option for the corresponding parameter, it must be tuned. The two selections are here, ASCII as well as RAW. So when you select the RAW, the received stream is treated in the RAW format as it is. And when you select ASCII, the received stream is treated in ASCII formats. Number of bits. The number of bits for received stream can be selected here. It can be 7 bits or 8 bits. And there is a stop bits, and there is a stop bits of 1 bit and 2 bits. Then there is a message delimiter. So you have a two option to select, that is LF and other. So other, it can be configured by the user, for example a symbol. And then there is a serial output. You have RS-232 and TTL. Then there is a bit rate. So you can select the bit rate up to 115 to 100 bps bit per second. And then there is a parity type. So you have a 4 options: odd, even, mark and space. It is dependent on the connected device on this port. And then you have a maximum packet size. So the possible values are between 64 and 1500. It is the maximum size of one TechMP frame which collect received messages on this port. So for details you can go through the TechMP specification. And then there is an RX timeout. So the TechMP frame is sent even if the maximum packet size is not reached. Let's go to the new tab, and that is XCP. So we have two options here: XCP on CAN polling and XCP on CAN and FlexRay. So this is the home screen for XCP configuration. Basically, XCP is the extended CAN protocol. By this option, you can request further information from your device under test over CAN bus if this is available for the specific device under test. For automatic configuration, you need a specific A2L for your device under test and a specific XCP tool. And you can contact us for further information with the tool. If there is anything already configured, after every software or hardware reset, CAN combo will restart with XCP. And now, what is CAN XCP on CAN polling? So here you can add more entries, and you have an option of interface ID when the CAN port XCP is activated, and suppose, and then you have a CAN ID of the request, and then there is a, you can select as 22, and then there is an address. It is the starting address of the memory range in the XCP slave, and then you have a size, and that is message size, length of information in the memory range, and then you have a message cycle, so it is in millisecond, how often the request message should be sent. So assume it should be sent in every 1 second, and then you can continue. So 1 second is not possible, and let's save this. This is how you can configure XCP on CAN, and then you need to click save and apply configuration. So the next option is XCP on CAN and FlexRay polling and DAQ. Here you can add new entries for the XCP for CAN and FlexRay DAQ by importing a JSON file. Usually it is better to use a JSON file within the data. This can be generated by you. So you can here import. So here you have an option of interface ID, FlexRay slot, FlexRay offset, FlexRay repetition, and default message cycle, import JSON. So offset, FlexRay repetition, offset must be smaller than the repetition. Remember that, and then you can save and you can go ahead. Now we'll move to the control message tab. So this will allow you to configure rules where to specify that a CAN message is sent by a capture module when a control message is received on the configured control message port. So on this tab, an overview of all configured user event is shown. You can see here index, user event ID, event, everything is shown. You can create a new entry by filling all these details, and you can also have an option to delete the table. So this is all about the CAN combo that we have on our shelf, and you can contact us for any future project collaboration using these devices. Thank you.